Question 16 asks, if the ball reaches the ground at t equals 2 seconds, what is the height of the building? So in order to figure this out, we have to assume, or we say that when t is equal to 2, the height is equal to 0. So if we have height as a so to get height as a function of time, that's really just the y displacement, and what we're working with here is the y velocity. So the y displacement can be given to us through the integral of the y component of the velocity. So we have the integral of v of t dt, which is equal to the integral of r minus st, or the integral of 5 minus 10t, which is equal to 5t minus 5t squared plus c. So then what we can do with that is we say that 0 equals 5 times t equals 2 seconds minus 5 times 2 squared plus c. Or actually, yeah, so we have 0 equals 10 minus 5 times 4 is 20 plus c. So we have 0 equals negative 10 plus c. So 10 equals c. What that tells us is that the function for displacement is equal to negative 5t squared plus 5t plus 10, which we can then use to find the initial height of the object, because at t equals 0, the ball was at the height of the building, because that is when it was thrown up from the height of the building. So we just plug in 0 for this. We can call this like y of t. So y of 0 equals negative 5 times 0 squared plus 5 times 0 plus 10. So y of 0 equals 10 meters. And that's what we have right here. With number 16, we have if the ball reaches the ground at t equals 2 seconds, the height of the building is 10 meters. Can draw a graph of that. There. And the integral of the velocity function that we were given could have been at a different y value because of that plus c. However, because it told us that at time equals 2 seconds, the ball hit the ground, that allowed us to algebraically solve for c, allowing us to use that function for the y displacement to solve for the height of the ball at t equals 0 to find the height of the building.